All right, grade 7, we're going to be working through triangles. So let me just draw one here for you. Um, and we're talking about similar angles in triangles. Well, we're not doing so well. But say we have two right triangles and they're marked off. Now mine don't look that way, but they're marked off like so and like so. These little ticky marks that they show that these two angles are exactly the same. Okay, so they're similar triangle, right? So if this angle and this angle are the same, then you'll know by the fact that triangles work that way that this angle is going to be the same as this angle. When they're similar triangles, then you can make you can figure out the lengths of sizes of the bigger one based on the smaller one, because they're exactly the same projection of size. The angles are exactly the same. So what I'm going to do is go with me to page 673 of your book. And we're going to go through the practice set. So make sure you follow along here. And it asks in A, identify each pair of corresponding angles and each pair of corresponding sides in these two triangles. So if you look at the angles, angle W, and angle R are the same. Angle Y and angle Q, Q are the same. Angle X and angle P are the same. Now in terms of sides, I'm just going to go line WX and RP are the same. And let's see, YW and QR. And then you have YX and QP. Those are all going to be similar. All right, and let's go to the next one. Refer to the figures shown to answer the problems in B and E. And I'm just going to draw them so that we have something to refer to while we're going here. But we have triangles here. It's got X here. It's got a 6 here. It's got a 12 here. And just slightly larger out here, it's got a 9, 12, and a Y. So we don't have all of the measures, but here's how you can see how we're going to get them so they work together. Right? So we know that this angle here is the same as this angle here, this angle here, this is the same as this angle here, which would actually tell you that this angle is going to be the same as that angle on those triangles. Doesn't really matter for this point. So that what they're going to do is ask you for B. It says find length X. So what you're going to do is look for the corresponding line. So if we actually go through it, you're going to see that this line here and this line here are the same. But that doesn't help us all the way out unless we look at the two that we have that are the same. So if this one's 9, this one's 6, you can see that in order to get from 6 to 9, we're multiplying by 3 halves. I'll just show you this quickly. 6 times 3 halves equals 9, right? Because this winds up being a 3. This is gone now, and 3 times 3 is 9. So you know that your scale factor is actually 3 halves. So it should be easy to go backwards to the 9, to the 12, sorry, right? So 12 divided by 3 halves equals 12 times 2 thirds equals 24 over 3, which equals 8. My best guess would be 8, which also answers C, which finding X is going to be 8. I just showed you 2 steps there in one. Again, we're going from here, it's 12, right? Here it's 12. You know this one's going to be bigger, right? Because we're multiplying it by 3 halves, right? So that's 36 divided by, 12 times 36 divided by 2, I would guess 18. And of course, your answer is also going to be 18 because I'm showing you how to kind of quickly do it in your head. And this one was fairly easy to do in your head. The other ones, the next questions, F, if you know how this works, that should help you figure things out a wee bit. But it says here that we have a tree, and I'm quite an artist, that casts a shadow, all right, that is 18, it says feet long, all right, and it says that a pole, right, and it says that that pole is 6 feet, casts a shadow that is 9 feet long. So you can see that we have some numbers, and it's saying, how can we figure out how tall the tree is, right? So you can see that our scale factor, if we're looking at this full length, that's 18. If we're looking at partial length over here, that's 9. So if we go 9 or 18 over 9, we know that, oops, I don't know why it's not doing that. Our scale factor is 2, right? So that would tell us if we make it 9 over 18 equals 6 over what? Right? And that would tell you right away, because it's a double scale factor, that you'd have 6 over 12. So both of those fractions actually equal the same thing. So your answer is that this height over here is 12 feet. Hopefully that made sense. Let's move on to G. Try this one on your own first and see if you've got the concept. So Donald stood next to a pole supporting a basketball hoop. He noticed that the shadow of the pole was about twice the length of his own shadow. Okay, so Donald is 5'6". 5'6". So there we go. We got Donald, and he's 5'6". 5.5 feet. Right, and we're noticing, and you can hear by the language there, that this basketball hoop, and I'm a terrible artist, so this basketball hoop, okay, its shadow is about twice its length. So it's pretty easy to figure out that Donald's shadow is coming out here. This basketball hoop shadow is coming out about twice as much. So that would mean that your scale factor is 2, which means that his height would be 11 feet, roughly, for the basketball, because all I did is multiplied this smaller triangle, right? This was 5.5, right? This is x, and this is 2x. We don't know this number, but you can see that the scale factor is times 2, and that's how we get the answer. So grade 7, make sure you do every